Hello everyone. Today we are going to see the experiment, inorganic chemistry experiment. Here we are going to study how to analyze bronze alloy with respect to copper and tin. Actually, this bronze, it is one of the alloy of copper and tin metals. Okay, these two metals are present in the bronze alloy. Copper, majorly the copper is present, its percentage is near about 88%, and tin is present near about 12% by weight. Okay, now in this experiment, tin we are going to determine it from the bronze alloy by gravimetric analysis, and copper we will determine it by using volumetric analysis. Again, in volumetric analysis there are 4 to 5 types, and out of that we are going to use iodometric titration method for estimation of copper. Okay, so first of all we will see how to estimate tin from the bronze sample. Now, tin in the bronze is generally determined gravimetrically by precipitating it as metastannic acid. That is, if you take bronze sample and if you add nitric acid in the bronze sample, then what will happen, the tin which is present in the bronze, that is precipitated as metastannic acid. The formula of metastannic acid is H2SnO3, and after igniting this H2SnO3 precipitate, you will get stannic oxide, that is SnO2. Okay, SnO2 you will get here. That we can from that SnO2, weight of SnO2, we can find out the percentage of tin present into the bronze sample. Okay, now in this way we can find out the tin. Here I had given the reaction 3Sn plus H2O plus 4HNO3, it gives thrice H2SnO3 plus 4NO. Okay, now here HNO3, it also act as a oxidizing agent. So that is why the bronze alloy sample we are dissolving it in HNO3 only. Now the copper we can determine it by using volumetric method. Just now I told you it can be determined by iodometric method. Now here I had given the reactions for the iodometric estimation of copper, and it can be determined by using this iodometric method. Here copper 2 plus ions that are reacted with iodide ions, so that there will be a formation of copper iodide and iodine will be liberated, and then that liberated iodine we are titrating it with sodium thiosulfate, so that there will be a formation of NaI plus Na2S4O6. Okay, so in this reaction copper 2 plus is reduced to copper 1 plus. Now the liberated iodine is titrated with standard solution of sodium thiosulfate. Before doing this sample titration, that is before titrating copper 2 plus with sodium thiosulfate, we will have to do the standardization of sodium thiosulfate. Okay, here I had given one equation, and by the use of this equation we can find out the amount of copper present into the bronze sample. Okay, this is, we can say that this is your standard equation for calculation of copper from the bronze sample, and the standard equation is 1 normal 1000 ml sodium thiosulfate pentahydrate corresponds to 63.54 gram of copper. Chemicals required: bronze sample alloy, then concentrated HNO3, nitric acid, 0.025 normal sodium thiosulfate, 0.025 normal potassium dichromate, 10% potassium iodide for iodometric titration, then 2 normal NaOH, concentrated HCl, acetic acid, and finally starch indicator. Now the part first of the experiment is dissolution of the alloy. We will weigh the alloy, whatever alloy sample, we have to weigh it, and we will add 10 ml concentrated HNO3 and we will heat the solution. We will heat the bronze alloy sample with that of HNO3 so that the alloy sample will get dissolved completely into the HNO3. Okay, and but here we will not get the clear colorless solution because the tin will be precipitated as metastanic acid. So here small particles of metastanic acid, we can see it in the conical flask. Okay, dissolution we will do it in the conical flask. Okay, then we have to filter the precipitate, that metastanic acid precipitate, we have to filter it through Waterman filter paper, and on filter paper we will get a metastanic acid precipitate, and filtrate contains copper. In this way we can separate copper and tin. Okay, and filtrate, it contains copper, that is why we have to dilute it to 100 ml. Now tin is separated and we have to determine the copper from the filtrate. Okay, now in estimation of tin, whatever precipitate we got for that metastanic acid, that we have to weigh it in a we have to first ignite it, and then we have to weigh it in a silica crucible. Okay, which should be previously weighed silica crucible, and by the difference of the empty weight crucible and residue plus crucible weight, we can calculate the weight of the residue. Now next part is estimation of copper iodometrically. But just now I told you, before estimation we have to do the standardization of sodium thiosulfate. Sodium thiosulfate, it is a secondary standard substance, so we cannot use this normality as it is. Okay, in the calculation we should have to do the standardization of sodium thiosulfate, and for doing this we will take 10 ml of potassium dichromate into a stoppered bottle. Always remember that whenever you will do the iodometric titration, you will have to do it in a stoppered bottle only. Don't use conical flask for iodometric titration. So we are taking here 10 ml of potassium dichromate solution, 0.025 normal, in a stoppered bottle. In that we are going to add 3 ml concentrated HCl and 10 ml 10% Ki solution. The bottle should be stoppered and it should be placed in a dark for 2 to 3 minutes for liberation of iodine, and that solution we have to titrate against sodium thiosulfate till you are getting a faint yellow colored solution. And after getting this faint yellow color solution, we have to add 1 ml of starch indicator solution, so that the solution color will be blue color. And after titration, we are going to continue the titration with sodium thiosulfate. We will get end point as blue to colorless. Here blue color, blue to colorless, this is your end point. And in this way we have to take 2 more readings, and finally we will write the CBR, constant burette reading, as XML, and from that we can calculate the normality, exact normality of sodium thiosulfate solution. Now after doing standardization, we can calculate the copper 2 plus ion by doing the sample titration. Okay, next titration we have to do is the sample titration. Now there is a difference in the standardization and sample titration. Here we have to determine copper 2 plus, so we will take 10 ml diluted sample solution in a stoppered bottle. In that we are going to add 2 normal NaOH solution drop wisely. Okay, now after addition of 2 normal NaOH solution drop wisely, the turbidity appears into the solution. Okay, bluish colored turbidity appears, and that is nothing but your copper hydroxide, okay, which is formed by addition of NaOH. Okay, NaOH neutralizes the solution, and At an alkaline pH, we will get a copper hydroxide precipitate. Then we are going to add acetic acid by drop till the turbidity dissolves completely. Now, acetic acid is a weak acid, and we are adding it to make the solution just neutral solution, or that precipitate we are going to dissolve it. Okay, to add then after that we are going to add 10 ml 10% Ki solution, so that copper will react with the iodide ions, and again this solution we will place it in a dark for 2 to 3 minutes, so that iodine will be liberated. And after that the liberated iodine, we are going to titrate it with sodium thiosulfate. And at this point you will get a faint yellow color to the solution, and then we are going to add 1 ml starch indicator. Okay, after adding starch indicator, we will get a blue color to the solution, and we will continue the titration similar as that of your standardization, and we have to continue the titration till we are getting end point from blue to milky white. In case of standardization, we got the end point from blue to colorless, but here we have to do the standardization from endpoint. Endpoint is different here. Endpoint is from blue to milky white. Now here we will call the reading as Y1 reading. 2 more reading we will take, and we will calculate or write down the constant burette reading, and from this constant burette reading we can calculate the percentage of copper present into the bronze sample. Now in here I had shown the observation tables which can be written for tin. First we will discuss about the tin, how to calculate tin percentage from the bronze alloy. Here I had written the observation table. W1 is the empty weight crucible, then W2 is the weight of the crucible plus residue. Here residue is stannous oxide SnO2, and weight of the residue we can calculate by subtracting W1 from W2. Now we don't want O2, okay, we want only Sn, so that is why we will use the relation 1 mole of SnO2 corresponds to 1 mole of Sn, and therefore 150.79 gram of SnO2, which is the molecular weight of SnO2, corresponds to 118.7 gram of tin, and therefore W2 minus W1 gram of SnO2 corresponds to how many grams of Sn. Okay, and this will give you the weight of the tin which is present in your W gram of bronze sample. Now as we have to calculate here percentage, we should have to convert this to 100 gram. Okay, that is W gram of given bronze sample contains A gram of tin. So 100 gram contains how many grams of tin? Here we will do the cross multiplication, and finally B gram of tin you will get as a percentage of tin from the bronze sample. Now this is the calculation for standardization of sodium thiosulfate. Observation table is written, and we can calculate the normality of sodium thiosulfate by the use of the formula N1V1 equal to N2V2. Here in the picture I had shown the end point of the titration. It is purely colorless titration. Okay, from colorless end point, it is from blue to colorless. This is the titration of the sample solution with sodium thiosulfate, and the same kind of observation table we will write here also, and the end point will be different. See, here I had shown two pictures. In one picture blue colored solution is appeared, and in the second picture, that is the end point of the titration, which is milky white. Okay. In calculations, we will use the standard equation. 1 normal 1000 ml sodium thiosulfate pentahydrate corresponds to 63.54 gram of copper. Okay, so whatever calculated normality that we will write it below normal. Then the burette reading for sample, that we will write YML, and it corresponds to how many gram of copper, that we will calculate by cross multiplying. Then this will give you the copper content in 10 ml diluted sample solution, because we have taken only 10 ml diluted sample solution for titration. Now we have to calculate the copper in 100 ml diluted sample solution. Okay, so we will use the equation. 10 ml diluted sample solution contains a gram of copper, therefore 100 ml diluted sample solutions, how many gram of copper? And here we will do the cross multiplication, and final percentage of copper we will calculate it now. W gram of bronze sample contains C gram of copper, therefore 100 gram of bronze sample contains how many gram of copper? Here also just we will do the cross multiplication, and we can formulate the result table as first point is percentage of tin in the given bronze sample. Second point is exact normality of sodium thiosulfate solution, and we will write it in the normal unit. Third point is percentage of copper in the bronze alloy. Okay, in this way we can do this experiment. Now this is nothing but the picture of metastannic acid precipitate after drying. Okay, after drying it is looking like this. You can see in between the white. Today we are going to do the analysis of bronze sample for estimation of copper and tin. Now this is a bronze sample, and from this bottle I have taken one small strip of bronze sample in this paper plate. Now I am going to transfer this in this conical flask for dissolution purpose. Okay, first we will do the dissolution of this bronze sample. Okay, we will do the dissolution in HNO3 acid, this nitric acid. I am going to transfer this bronze alloy sample in conical flask. Now this is nothing but concentrated HNO3. Now I am going to add this 10 ml concentrated HNO3 in this conical flask. Now we have to heat this solution for dissolution. We are going to heat this solution till the sample gets dissolved completely. This tempered funnel, it is acting as an air condenser. Therefore, I am going to place this tempered funnel on conical flask in this way. Now we have to heat this solution till this bronze sample, it will get dissolved completely. sample is dissolved completely. Sample is dissolved completely, and you got a precipitate of metastannic acid. Okay, this is nothing but a precipitate of metastannic acid which we got in this conical flask after dissolution of bronze alloy. Okay, now I am going to add water from here. We have to cool this solution. Now I am going to add distilled water from here. Now we should have to filter this solution through Whatman filter paper 42. So we will filter this solution. This is, you can see the precipitate of metastannic acid. This is the metastannic acid precipitate. The precipitate we will transfer it to this is your precipitate of methastanic acid, and this methastanic acid precipitate we have to dry it in oven and then we have to ignite it. Okay. Then this methastanic acid after ignition getting converted into SnO2. This diluted sample solution you should have to dilute it to 100 ml. Okay, now this is the filtrate, and we have to dilute it to 100 ml in a volumetric flask. Distilled water. This is your diluted sample solution for bronze sample. Okay. Now, from bronze sample we are going to estimate copper iodometrically. This is nothing but the diluted sample solution of bronze. I have filled this diluted sample solution in this burette, and from this burette I have taken 10 ml diluted sample solution in a stoppered bottle. Now I am going to titrate this solution with that of 0.025 normal sodium thiosulfate. Now before titrating, first we are going to add this NaOH, sodium hydroxide, 2 normal sodium hydroxide to this sample solution till just turbidity appears to the solution. Now I have taken this sodium hydroxide solution in this beaker. Now I am going to add this sodium hydroxide solution in a stoppered bottle so that just turbidity appears. You can see the bluish turbidity in the titration flask. This is nothing but a bluish turbidity which is formed in the titration flask. Now I am going to add acetic acid, this acetic acid to this solution till turbidity gets dissolved. I have taken this acetic acid solution in a beaker.
जुना लॅपटॉप लावला.
See, the turbidity is completely dissolved. Now in this solution we are going to add 10% potassium iodide solution. Now I have taken this 10% potassium iodide Ki solution in this measuring cylinder. 10 ml Ki solution I have taken. Now I am going to add this solution in this bottle. Okay, stopper the flask, and now this bottle we have to place it in dark for 2 to 3 minutes. This solution is titrated with sodium thiosulfate solution. Now we will add, I am going to add starch indicator to this solution. You can see the color. This is nothing but the color before titration. Now we are going to titrate this solution with that of sodium thiosulfate solution till we are getting end point. Now this is the end point, which is milky white. In case of copper, when you are estimating copper by iodometric method, you are getting end point from blue to milky white color. Okay, this is nothing but your end point of titration.